Some people might be watching the stream, so that might be another thing. So
yeah, if we do watch the stream, we still don't sign roll.
well,
Because I couldn't make it Tuesday, but I watched.
if right, well, you can only sign a roll in class.
Yeah.
So if you watch the stream, you won't be able to sign the roll.
Right.
But the roll doesn't hurt. Remember?
Yeah.
You know, I don't make it where I'm taking points or giving points just because you're coming, right? But it's easier or better when you come and we go over stuff and you can actually ask questions and do whatever. Right? But sometimes you have situations where you just can't come.
Yeah.
But the stream does help. All right. So should open up back up there. All right, so let's open this up. And now we gotta kind of move a little at a little faster pace. We went through a program to see what it actually does and whatnot, and we went through some of the commands and whatnot. Okay. Chapter 2. All right, we went over this little small assignment here. That printing that. All right. This is the flowchart. This is the pseudocode. The pseudocode, looking at this, it just says what? Display a name, display a street address, display the city, state, zip. Correct? But then when we look at the flowchart, all right, flowchart, start, display the name, display the input output, display in the input output, street, display in the input output, city, state, zip. Right? So this is the flowchart. Pseudocode and flowchart, similar. One is actually written in words. This one is actually using symbols. All right? And we saw that this would be our output, correct? Name, street address, and then the city, state, zip. All right. Now, and these are called, anytime it's in the double quotes, strings will be string data. So it's like a string is what? A series of what? Characters. Numbers can be what? Character data, right? Dollar signs, special characters can be string data. Whatever you put in those double quotes would be considered strings. So programs almost always work with data of some type. For example, in program 2.1, it uses the following 3 pieces of data: the string of the name, the string of the city, of the street address, and the string of the city, state, and zip. Right? These pieces of data are sequences of characters. What? From the beginning of the double quote to the ending of the double quote. Sequence of characters. Right? If I told you I wanted you to output Baton Rouge Community College, all right? But I didn't want you to declare it, I just want you to output that string. You would do what? C out, and then what? The stream, and then double quotes what? And double quotes what? Baton Rouge Community College, all right? So that's the string of characters I would want you to print, all right? If I told you to print out your name from a string, C out, you know what I'm saying? And then the stream, and then in double quotes, whatever your name is. Okay? Everybody got that? If I told you to print out a label, like say you're writing a program to calculate the sum of 2 numbers, and I say, but I want you to print out a string that labels the value of the sum of those numbers, and I told you I wanted sum, semicolon with a space, you would do the C out, stream, and then double quotes, sum, with a semicolon and a space, right? And then you would give me the what? The value. So that's all this is talking about, string data, all right? All right. So it tells us that when the string appears in the actual code of a program, all right, pseudocode, as it does in program 2.2-1, it is called a string literal, all all right? The program code or pseudocode, a string's literal is usually enclosed in what we said? The quotations or the double quote, all right? So, variable input. We know when we input data, we use what command? CN, remember? That CN allows that program to wait for data to be accepted from the user, all right? So we went over that. So here what? In pseudocode, you probably see something like input hours or retrieve hours or get hours. When you see something like that, that means the system is trying to what? Bring something in to get it so it can use it for something, all right? So these are some of the keywords for getting something from the keyboard or from a file or whatnot. All right? So, look at this program. All right? This program does what first?
Output.
Outputs what?
What is your age?
Right, and what that is?
Quotation.
But what it is? What we just talked about?
String.
A string, right? We call string literal. All right? Now, in the second, in line 2, what it says? Input age. So what command we'll use here? CN. So we'll CN age. And I'm going to go back and talk about something else in a minute. Then it has what? What type statement? It say display, which is output. We use what? See out. And in our string literal, we will have what?
Here's the value that you
Here's the value that you entered. And then we're doing what? Displaying what? The actual value that was inputted, giving it back to the user. All right? But there's one thing in this particular pseudocode that's missing, and it's very important for programmers. You need to have or define your variables that you're going to be using in the program. Because when you start writing your code, you cannot just say display what is your age in CN age, because the computer does not know what age is, because we didn't declare it, right? Yes, sir.
So what happens if you have like name and age?
Then it's two separate ways with name. Now, if you just inputting the single like a single word name, you can use CN. If you're inputting a name with a space in it, then you would have to use get line. You know, the CN.get line or get line, CN, whatever, because you want to get from the beginning all the way to the end of when you hit enter. All right. Now, another, and you may not have to worry about it with the programs I give you for this class. Another thing you may have to worry about is the program skipping an input. All right. What happens is, when you type something from the keyboard, that information is in a keyboard buffer, right? As long as you input numbers, you don't have any problems. But when you input character data, it reads from the beginning up until the characters that you type. But what happens, it leaves like the \n or the return key in the buffer. And if that's still in the buffer when it hits another CN, it'll throw that in the buffer and will not allow you to input another value. So there's a command called .ignore, all right, called ignore. And you would do a CN.ignore, mean you just want to input that value, but you're ignoring it, and then when you prompt it for the value, it'll allow you to input it. But we'll get to that, all right? So let's take this program, and what I'll do, I'll write it real quick to show you, and we'll do it together, how it actually is written. So what I'll do, I'll slide this over to the side. I'll open up online GDP. If I can get it. All right. Open up online GDP. And now, remember what I said about the program. What we need to change the what? Change the program to the compiler to C++. All right. So what we'll do, we'll just take all this out and let's start afresh. All right. Now, what we want to do, our shell, pound include IO stream, and this IO stream allows us to do what? We load in the library that allows us to do what? Input and output information, right? Without that, we'd have some issues. All right, using namespace. All right, load the standard libraries, int main. And main is our function, all right? And that function is necessary. So now all we're concerned about now is what? Writing our logic for the program, all right? Now, looking at this here, what do we say we needed to do first? We have, say we input age. Does the computer know what age is, or the program know what age is? So we need to put what age is. Now, as a programmer, you have to make some decisions, okay? Data type, okay? The name that you're gonna use as the variable. So what's a good variable that we're gonna use to represent age?
Age.
Okay, so we'll use age, all right? We can just use age. So you could say persons dash age, person dash age, whatever. Long as it's what? One word, doesn't begin with a number, and what? No special characters. All right, so if we do that, we'll do something like, now another thing you need to determine whether or not age will be what? We type it in or what for age? What are we gonna type in? A number, right? But now you said a what? A whole number. Now, then depending on what the program is to be doing, you may say, well, no, I don't want a whole number. I want in a fraction. If somebody is 12.5 years old, I want to put 12.5. You know what I'm saying? Because it might be some type of formula that's being used to do whatever based on age. I'm just saying. But you as the programmer need to get with either if it's the company or either the person you're developing the software for and decide how will age be represented. Right? Is it a whole number or is it a decimal? Right? And once you all come to that determination, then you would know how to actually get that data. So I could do int, if we're gonna do whole number, age, right? I've just told the system I want a variable within my program called age so that I can use. Everybody got that? So now, but then remember what I said about the CN. When you input something, you always proceeded, or most often will proceed it with a what? That CN gonna be preceded by a cout to let the user know what it is you want them to input. Otherwise, you're looking at the screen and saying, "Well, when it's gonna finish executing, right?" But it's executing, but it's just waiting on you. So here we would say, okay, cout, and what we want to put in our as our string.
What is it?
Yeah, right. What is your age? Right? Question mark. Now, here at this point, like I said, two different things you could do. You can go at the end and stream a inline, where you would accept the data on a new line, or if you're going to accept it on the same line, I would tell you to put a space after the question mark so that when it's receiving the data, it's not all jumbled up next to the label. Okay? Everybody understand that? All right. So I'll put that space and then question mark, and then I'll end it with a semicolon. Now, the next statement would be what? Simply CN, right? CN age, right? Right, Clyde? So we CN age. So now we've inputted, we're in the process, we've inputted the age. Now what do we want to do? Output the label along with what? The age that was entered. So at this point we would say cout and the same thing here I would put a space after the colon and then then put the double space, the double quotes, and then I would stream out age, all right? And then maybe an inline to make all the other compiler information move down one, all right? And basically that's what this code does, or that pseudocode is, all right? Everybody see that? The only thing we added to this was what? Declaring the age, okay? Display, what is your age? See out, what is your age? Input age, see in age. Display, here's the value that you enter. See out, here's the value that you enter. But then rather than do another see out, I just did what? Stream and then age, right? Everybody see that? Okay? All right, so let's run the program, see what happens. When you run it, remember Miss James, when you write the code, you're the programmer. But then when you executing it or testing it, you got to have the mindset of the user, all right? So we've created a program, now we're testing it, all right, as the user. So it says, what is your age? Give me a number. 21. All right. Now, when the CN got the saying, okay, enter the number, it's still waiting for me to do what right now? Hit the enter key. So CN will be waiting until I hit the enter key, all right? Because I can add numbers to that, drive it back or whatever. So now when I hit enter, it will accept 21 and store it into the variable age. And then the program going to continue and it's going to say what? Here's the value that you entered, all right? So now you might look at this output here and say, well, it's a little different from what we type, okay? A simple fix to that is this, all right? You can either use the \n or the inline. Here I could do this, see out that stream NL, okay? So what that's gonna do is gonna prompt the message and go to a new line, and it's gonna wait for you to input the value on the new line. And for the second one, okay, we could do this and then say see out age in that fashion. So now when I run it and I put 21, see, notice where it's accepting it at? On the next line, because I put an inline at the end of that statement, right? And then when I hit enter after 21, oh, wait a minute. I didn't use inline. I didn't use inline here, okay? Or I could do \n, all right? Either one will work. So let's run it again. And I'll put in the 21, and then look, 21. So it's basically the same, right? Everybody understand that? All right, so that's taking pseudocode and writing the program from that pseudocode, all right? So, displaying the age. Now, this thing gives you an example saying that when I display age or see out age in my program, if no double quotes are around the word age, it's gonna print out what? When I say this statement here, where am I? This statement here. If when I say see out age, what will it output at this point?
The age you picked.
Whatever age that was inputted. But if I do this, see out age, what's going to output?
Age.
The word age, because now it becomes just a string. It's not the variable, it's a string. So when I run this, watch what happens, okay? What is your age? Say put 21. Hit enter. The value here's the value that you enter. Age. And you'll be like, man, what's going on? Why my program doing whatever? It's because you put those double quotes around age and made it just a string. All right? You got that, Miss Jane? Yeah. Oh. You understand?
You can do anything now. You can do that with the number too, right?
Right, correct. Right. Example, say, I could put 21 here, all right? Right? And when I run this, All right. So I'll put in 5. I'm gonna just show you. And when I hit enter, see what happened? Here's the value entered, 21. Because what? It's printing what's in the double quotes. It ain't printing the actual value of age. So let me run it and do age as 21 to show you the same thing. Age, what is your age? 21, right? Now, some people might turn a program like this in, but that program would be actually what?
Wrong.
Wrong. Everybody understand that? It would be wrong. Even though the output looks like it's right and whatever, it would be wrong.
Because you want that program to do multiple things, right? If you don't do that one.
You want your program to be versatile.
Right.
You understand? You don't want it to just be one-sided to where it only do this and that's that. You want it to, like say, for the input, you want it to be able to input any age. And when I get that age, I can do whatever with it, right? Not just say, okay, I just want this age and that's that.
Right.
Okay.
It's like the gross pay. You just put 40 in the quotation, 20 in the
Correct.
pay rate and stuff like that.
That's
it's not
right.
The same thing every time.
Yeah, you'll get the same thing over and over and over. That's right. All right? So, variable names, we talked about variable names, right? I'm gonna give you a quiz after the class, at home so you can do that. I don't think I gave it to you on this last one, right? But you'll have it, right? It'll be a quiz. I'll have different variable names listed, and all you have to do is tell whether it would be valid or invalid. Okay? All right, but if you look here, you have gross pay, 1 word, rate pay rate, 1 word, hot dogs sold today, 1 word, that all valid. Here you have gross underscore pay, pay underscore rate, hot underscore dogs underscore sold underscore today, all or what? Valid. Now, if you look at this though, that's what I was saying. You as a programmer, gonna come up with a programming style. Okay, some people might love this way where you're putting an underscore in between each particular word to make it more readable, but it still look like 1 word, but look like a sentence, but you got an underscore in between each. Some people do that because they want a variable where they can know exactly what it is, right? Some people may do it this way. Nothing wrong with it, right? Programmer's style. So, and many times, and as you grow, you'll see. When you start writing code, and if ever you see some code, you'll be like, wait a minute, that looks like my code. Because you're gonna have that style and you're gonna always recognize your style. All right? You could call it your signature, stuff that you do. All right? So each one would be valid. All right? Now, here they talked about, and we talked about earlier before, camel case. Camel case would be something like this. You got gross, but then you got the P is capitalized on pay. Here you got pay, the R is capitalized for rate. Here you got hot dogs sold today. The D in dog is capitalized, the S in sold is capitalized, and the T in today is capitalized. That's called camel case. All right? Like the hump in the camel. That's all they're talking about, up and down levels. All right? Okay. Now, displaying multiple items with 1 display statement. That's what you just saw I did, but let's do it, okay? What it's saying is, display of what is your age, all right? And then input age. Now, this is how we wrote the program the first time. And then when we output, we're gonna output age. Well, here's the value you entered and age all on the same line, okay? So that's what they're saying. So remember when we first wrote it, we wrote the program somewhat like this. I'm gonna take this off and put this back right. We wrote the program somewhat like this where all right, I need my double quotes. All right, we wrote the program somewhat like this where it would print out the value you entered, entered along with the age, but it was 1 cout statement, okay? 1 cout statement. So, and sometime I might give you an assignment and I might say, okay, use X, Y, Z, whatever variables, and I want them all outputted using what? One cout statement or something like that as we move on and do whatever. So, because what happens is, if I had a program where I had something like this, int x equals 4, y equals 5, z is equal to 6. Now, if I wanted to output all those, the value of all those variables, but I want to do it with one cout statement with a label saying x is equal to whatever, y is equal to whatever, then I would have to put my streams here in between the label, the value, variable, the label, the variable, the label, the variable. Okay? So I'll show you that right quick. So that's something like this. Cout, all right? And I'm gonna just do another inline, just a double space. All right. So I would do cout, and then if I wanted to output x, okay, x equals, all right, space, and then I can stream what? X, all right? But then now I wouldn't put a semicolon, all right? I would do stream, and then double quotes, y equals, all right? Well, first of all, I'd have to put a space or two, or I could do a /t. So what? It'll tab over, right? And there's something called where you can do a column, set the column width, but that's further on in the course, and I will show you how you can do column width for each variable that you output. All right. So I'll say y equals, and then I'll stream y. All right. Then here I would say, okay, again /t, and then z, all right, equals, and then double quote, and then I'm gonna stream z, all right, and then I'll inline. All right. So what have I done? Cout, I'm outputting a string, x equal with a space. And then after that, it's going to stream the value for x. Then I'm going to tab over, printing out a string that's going to tab over, well, space first, which is okay. Space, we're going to tab over, and then print out y equal, and a space, and then then it's going to stream the value for y. Then it's going to stream out a tab, and then z equals with a space, and then stream out z, and then stream a new line. All right, so let's run it. All right, we run this program. Age, we'll put say 22. All right, the age you entered, 22. Look, x equals. I didn't put a slash. My fault. See, when I didn't put a slash, it didn't recognize it as a tab. It took it as a string of the what? The letter T. Right. So that was a mistake on my part. So let's run it again. And I'll put 21. Hit enter. Now, see, x equals, and then you got 4. Then you tab, y equals, and then you got the stream of the value 5. And then you tab, then z equals, and the value 6. All with what? One cout statement. Right? Okay, so you can have one cout statement to just stream all the bits of information that you need to output. Right? So that's all it was trying to show you here. All right? So basically that's what's done, all right? String input, all right? Now, we know how to just print out a string, right? Just doing what? Cout and put it in the double quotes, right? All right, so string input allows you to input a string value up until the enter key, and we're using the CN, and then allowing you to print that value out. So let's take our let's look at this and then we'll do that same program. Here it says what? Display what? Enter your name. Then what? Input your name. And then the rest of the program, not the rest, but the second two lines is basically from the other program, right? Display, enter your age, input age. And then it kind of got intelligent and said what? Hello, hello, whomever, you are blank years old, right? So it's almost like the computer is talking back to you, but you gave it the what? Information, all right? So just always remember that anytime a computer gives you information, it has to have it entered first before it can give it back to you. All right, so let's look at our program. So here, I'll take this out, but now we introduced another what into this scheme?
Another
Variable, you understand? So that variable is called what? Name. So here, now, name is of what data type? It's a string, but it's character, but character is a single, Shaw deals with a single character, unless you do arrays, all right? And that we'll deal with that toward the end of the semester. String data would be a series of characters. So, but this is the thing, I'm gonna introduce to you another header file that you need to load, all right? Pound include string, all right? So if you're gonna use a variable or a data type, which is not a true data type, string, you're gonna have to load that string library. You're gonna have to remember that because you'll be on the weekend trying to write a program and like, man, Mr. Buster, I tried everything. It just don't want to work. And I put everything in, I looked at it, I looked at the notes, it just don't want to work. And then somebody could come say, oh, you didn't use the pound include string library. And you're like, oh man, I spent 3-4 hours or whatever all weekend trying to get it to work and it didn't work. All right, so we'll put string here. And now once we do that, now we can use that string data type and we can say name without getting an error. Okay? So now we do string name, and now we can use name anywhere in this program. So do cout, what is your name, right? Question mark, and then cn what? Name. Correct? So all you're doing is adding that statement. Now, then we need to modify it to display like it said. So here, like I say, you're gonna be, as computer scientists, you're gonna have to learn to be creative because, you know, you're always innovating and creating things or whatever. We're gonna be, you know, writing code to do whatever. So here it goes, say, cout, hello, well, if I'm good type, hello, comma, and then you're gonna stream what after that? Hello, what? Name. Not the actual name that you're gonna put, but name gonna be whatever value that was entered for name, or string data that was entered for name. So I'll do name. All right. So it's gonna say hello name, and I'll do in line, so it'll go to a new line. All right. And if I went to double space, I'll put another in line, but I'll just leave it like that. All right. So hello and then name. And then what was the other information that they had? You are blank years old. All right? So now you will do cout and then what? You are, all right? Now, at this point, I'm going to put a space after R, right? Because I don't want the number that I'm streaming to be right next to the E. You got, everybody understand why I'll be doing that many times. So I'll do this, and now I'm gonna output what? You are what? Age, right? Because it's gonna print the number that was inputted for age. You are age, and then stream, and then I need to put a space again because I don't want age and the number to be what? Close together, the back of the number, right? So I'll put a space. You are age, year, they put year or years? Years old, okay. All right, so all right, period. And then what I could do, stream or inline. Okay, so now, if you look at it, name, something that was unknown. Age, something that was unknown. But we wrote the code to what? Grab that information, grab the name, grab the age. And then now, once we got the data, now as a programmer, you gotta present that data in the fashion that the user or the owner or the company owner wants you to present. All right. So when we run this, it's gonna. Oh, I got it.
On the first one.
Wait a
What
minute.
is it?
CNA. Oh yeah, I missed the semicolon on line 10. All right. So now when I run it, and hopefully I got all the errors on now. Now when I run it, what is your name? Okay, I'll put David. What is your age? Okay, I'll put 500. Whoa, I'm Moses age. 556. So and hit enter. Look, hello David. You are 56 years old. So see how it looked like the computer is actually communicating as a human, right? But it's not. You're the programmer writing that code and giving it back in a fashion to where it's like somebody talking to the user, right? Everybody understand that? Yes, sir.
Yeah, I was trying to do that earlier today.
Right. String.
But I didn't know how to have the string that kept popping up as UR0.
Right.
And I was like, well,
That's why it's good to come to class. All right, but that's how it's done. All right. So, any questions? Questions? Yeah. Oh, you already. All right. Questions? You wrote it. You typed it. Okay. All right. All right. So hopefully, typing it and going over what we're going over in the chapter kind of condition you to say, okay, see out, see in. Oh, I need my variables. This is how you do it. Whatever. All right. So prompting the user, we talked about that. You know, we prompt the user, see out, whatever, right? And whatever the string is. Then read the data, okay, see in, all right? So look, here it don't have input, it say read. But read, input, get, same thing, all right? So that's all this part is saying. We pretty much went over this, which is that program. That's the checkpoint, okay? Variable assignment and calculation. Now, what I'm gonna do here, I'm gonna break off from here and I'm gonna go to a section on the SYL site and show you a section where you can go to for some just some help notes. All right. So if I go here and we go to the to 1923, if you look here. Declaring, initializing, assignment, and pseudocode. So if you click here, you would get this screen, all right, this page. This gives you the rules for naming the variable. So if ever you got, say, well, man, I don't know what page it is in the notes or whatever, you could go straight here. Okay, must be one word, no special characters, cannot begin with a number, and it must be meaningful. All right. Now, one other thing about variables or user-defined variables is that you cannot use a reserved word. All right, a word that already have meaning in the compiler. All right, you should understand that you cannot use those words. Everybody got it. All right. So here we go. Valid names. Amount underscore paid. Valid. Phone 2. Valid. 2 is not at the beginning, right? Underscore takes place in the space. Here we go. Capital O, verb, capital T, IME. Camel case, right? That's fine. Count, capital C, capital U, capital T. Camel case. No problem. But look here, amount space paid would be wrong. It would be looking for amount to be a variable and paid to be some type of variable. Okay? Because there's two different words. Because there's no space. To phone will not work. Any variable cannot begin with a number. Cannot begin with a number. Then we have a special character. $sign phone. Cannot do it. Whatever. Parentheses phone. Single quote phone. You cannot do that. That is incorrect, and you will get errors. Here you have some data types. We already have used int. Int is for what type data?
number.
Whole number. Right. And then float is for what type number?
Decimal.
Decimal place. Yes, sir.
Okay, so just to be clear, you can put numbers in the first character.
Wait. Oh, in the variable name? Yes. Talking about creating a variable?
Yeah,
Yes.
a number can.
It can be anywhere except the first character.
Okay.
So give you an example. If I have 2 different or 3 different address variables, I could say address 1, address 2, address 3. They valid because the number is not the first character.
Okay.
Or I could say A1 DRESS, A2 DRESS, A3 DRESS, long as it's not at the beginning, right?
Okay, just making sure.
Right. Okay. Yes, sir.
So that's why on the gross pay we use float.
You use float for gross pay because now you can actually create a store a floating point value. Right. Now there is something later on we'll look at called static. What do you call static? What do you call? Forgot static. What you can do? You take a value and throw it into another data type and then use it, but you're not changing the actual value of the variable. All right, static cast. All right, you can take like if I inputted something as float, I could static cast it as say take the number 67. Not 67. No, 67 with the letter A, right? I could input 67. Is that right? 67? 64. What was the decimal value for the letter A? When we did it in class? I didn't show y'all that ASCII table. I'm gonna have to show y'all. All right. But anyway, I could take,
Table.
right. What I could do, I could input a letter, like the letter A. I could static cast it to an integer value and grab the integer value of that letter A from that ASCII table and present it, or use it to calculate something.
It's 65.
65. So, example, if I said that, okay, the code for whatever, we writing a program for the city, and we have the codes A, whatever, and say we write the program, and then whatever that code is, we're going to take that decimal value and use it in an expression to calculate something. We can't take A and use it, but we can take A, static cast it to an integer, and use that value in that expression. So you see how but it's still going to remain as that A character. All right. So that's some things you can do with C++ or whatever. All right. But here you got char. Char is a single character. A char data type can hold only a single character. Everybody understand it? Now, I'm gonna show you what I'm talking about. Look here. Remember our program here? We got string name, int age. All right. Say I wanted you to input your your sex. All right. So M or F. So I could say char sex, right? So now the only thing you could input in this field is one character. If you try to put MALE into it, won't work because it's what? A char data type. If you try to put FEMALE, one character. You understand? Char can only.
How often do you use that though?
Huh?
How often would you use that?
Okay, let me give you an example. But if I do this, char, sex, say 10. If I do this, now what this says, I can have a char value up to 9 characters. Up to 9. You understand? That's an array. So it's like a string in a sense. But you understand what I'm saying?
Yeah.
So you can take a single character, a data type, and make it a series of characters. Right. All right? So that's how you do it. But sometimes you have variables where you just have a single value, right? That you want to check. Example, if you write in a menu system and you have a list, 1, 2, 3, 4, 5, whatever, please enter your choice, And then you might go through it and say, do you want to continue? Y or N? You see what I'm saying? So you do have sometimes variables that only have one single, character of value, right? So if we look back at here at this, I should have stayed on the same page. Was it this? Let's see. All right. So if we look back here, char, a single character. Now this is the thing. Let me go back because I want to show you. If I want to assign this to a value, I could say sex is equal to single quote M. You understand what I'm saying? I cannot put double quotes because if I put double quotes, that's saying that it can be one or more characters. But char is only what? Single quote. Right? Unless I make it an array. Everybody understand it? All right. So you will use single quotes to initialize a value to equal to this. So now when I output this, right, and I'll say, okay, I'll do something like, I'll do inline, and I'll do cout u, and I'll do this, and then I'll put a space, and I'll say. Now watch what happens. I initialize, so I'm not inputting it, I'm giving it a value. So when I run this, see? And it printed the M, right? So see, single quotes. Now remember, char, single quotes, right? All right, so now, unless it's an array. Okay, so let's look back here. Then you got int. You got short int, and you got int, right? You say, well, why do you have the two? Well, like I said, they got smart with C and C++ and whatnot because what? A lot of times if you just have one default size for everything, you might write a small program that may not be using large numbers, but you have to take up byte sizes for just because that's the default size. So all of a sudden now you can kind of fit the size of your program to be minimal so it can what? Run faster. You got what I'm saying? So if we look here, short is int, but it only can hold 2 bytes. All right. So it's a variable that can hold 2 bytes. But now watch this. The smallest number that can be held in a short data type is negative 32,768. The largest number, and let's say if it's got a sign, negative sign on it, the largest number is 32,767. So if I'm now dealing with numbers shorter than that, or lower than that, or larger than that, greater than that, I could use short, and I'm saving what? Byte size, byte space. Now, you might not be concerned with that now because what? Hey, I'm just learning C++. I want to get my program right, and if it's right, hey, I'm straight. But as you grow in programming and you start writing code for gaming or writing code for businesses and those programs are large, you don't want to just use up all kind of memory space, and these are large programs and they're going to take more RAM to run, or take longer to run. You want to reduce that size, make it efficient to where what? It can run, with lots of speed. All right? But like I say, now you're not really worried about that, but you'll be worried later on as you start writing code. All right? Now, and then look at the int. Look at the size for an int, So you see it's considerably larger because what? The byte size doubled, right? I had 2 bytes for a short, now I have 4 bytes for an int. But they both whole numbers, represent whole numbers. But then look, you have float and double. Float data type, depending on what size of those float values, you don't want to go to a what? Double, right? Because, you're wasting space, taking up a whole lot of byte size. But depending, you may want to, just in case your division, you want to go to a certain decimal place or whatever, I have to get more specific. So it all just depends, right? So double is 8 bytes, right? And then bool, it's like Boolean, it's like say yes, no, on, off, true, false, something like that. So in your program, when you writing code dealing with if statements and whatever, you might turn something on. If that value is true, if that value is set to true, you're gonna be doing something. When it get false, you might kick out of a loop or something. So that's what that value is used for like just two values, true or false, on or off, yes or no. All right. So that's data type. But look here, variable declaration. Now we declared variables in this program here, right? Int, age, string, name, right? Look here, char code. We created a variable called code that's of char. How many bytes it hold? Char code. How many bytes it can hold?
One.
One character, right? Then I can know what? I can declare multiple variables on one line. Rather than do char code semicolon, char status semicolon, star switch semicolon. I can do char code comma status comma switch semicolon. All right. Same thing with int age. But if I had multiple variables to declare, I could do them all on that same line. Just like you saw me initialize x equals whatever, y equals whatever, z equals whatever. So all separated by a comma, right? So you can do it. Float, same thing. Float amount, just one of them you're declaring. Or you can say float amount, amount, comma, price, semicolon. Two variables, right? So that's declaring. Now, I don't think, I might have it. Assignment statements. Assignment statements is when you're taking a value of the left side, of the right side, and assigning it to the left. Right. You're taking something on the right side and assigning it to the left. Okay? Sometimes you may be overriding a value. Right? And sometimes that's when programmers get caught up in getting trouble. When they write code, no, but Mr. Sylvester, I mean, it's equal to whatever. When I said it at the beginning, yeah, but look down here, you said x equal 5. But then somewhere down here, you said x is equal to y. You know, so whatever y is, it changes, right? So that value of x would change. So that's how sometimes in programming we get caught up, be like, man, what's happening? What's going on? Where is it changed? And you have to look through the program and figure out where you're doing those assignments and what's going on. And then there's something called when you have the x plus plus, y plus plus, x minus minus, you know, a plus plus x. So, and we'll get into that and what that means, the pre and the post.
Equals.
Huh?
Equals.
Well, the equal is a logical operator, like greater than, less than, equal to, not equal to. And equal to would be two equals. One equal is a what? With the word up here, begin with an A? Assign, right? As an assignment statement. Example. I didn't want to do that. If I do something like this, all right, and I don't know if I can. See here, sex equal M, right? That's saying what? I'm taking what's on the right and assigning it to the left. Right? But really, in this part, we initializing because this is when we first introducing it, right? All right? So now, if I, in my program, and I have to show it to you. All right, watch this. I could do something like this. If sex equals M. I really have just messed up, class. And I'll close it here. All right, this is an if statement. What an if statement does, it compares values. Based on whether that comparison yields to be true or false, certain things will get done. Here, if sex equals M, but it says do this. If that holds true, do this. Okay, that's what that says. If it's not, we just gonna do return 0, which we do nothing. Okay, the program just gonna end. But there's a problem here because in that if statement, what are we doing? One equal does what? Assign. So every time we hit that if statement, what are we doing to set?
assigning it.
We're assigning it, which we making it to be, huh? Making it to be what? Right, which would be true. So I don't care if I put a F up here, it will still do that function, right? Watch this. So let's run it. And I'm gonna put my same information. I'm gonna run it. And I'll put David. And I'll put 56. Now, at the top, I said what? Female, right? But then that if statement, I only have one equal. So what it's actually doing is assigning sex to be M, so it's gonna automatically perform it because I just overwrote it. You got me? So when I hit enter, you got what I'm saying? And look, it's male. Now, if I do this, leaving as female declared, and I do this, now I'm comparing the two. What sex? What sex? F. Is F equal to M? No. So that means that it's false. So it will not do that body.
Turn to 0.
Right. And it's gonna do nothing. So now when I run it, nothing. You see what I'm saying? But as long as I have that one equal, it's gonna automatically do what it, regardless of what I have sex equal to prior to that, it's gonna automatically assign it to the
same
end.
way with like equals exclamation point.
No, but that's not
Not
equal.
equal, right? That's but I'm saying. The
No,
logic
just one equal though. Not
No,
equal.
yeah, that's what I'm saying. But the logic works the same way. So like, if it's not true,
It's
then
right.
it won't do the if statement.
Right. But if I say if sex not equal, if I can try it. Oh, I'm still in this. Not equal F. What is gonna do? Huh?
It's gonna mess up. Right?
Nah, well, what I'm saying, just follow the logic. What is gonna do? What's gonna output?
Right now, nothing.
Nothing.
Right? Yeah.
You understand? It says if sex not equal to F. So sex is what? And we asking if it's equal to F. Is F not equal to F? So that's false. So it kicks out. So you got to keep that logic in your head, because we all and I tell students, I say we and many people, we from the South, and we use double negatives all the time, and we understand each other. But the program, it doesn't do that.
Right.
You have to make sure you logically understand what's going on. You know, no matter how you was
One
raised.
little operator can mess up your whole.
Correct. That's right. And you're trying to find, where did I go wrong? What's going on? Because that's a logical error. That's not a syntactical error. That's a logical error. All right. So you got to be able to go through it, and sometimes you'll miss it. Man, you'll just be like, no, man, but I don't want it to equal to F and this, that, and whatever. And I can tell you, somebody who never looked at your code a day can come and look at it. Oh, right here you have X, Y, Z. Because they're looking at it objectively rather than, oh yeah, this is what we want to do. I know this is what's going on. Yeah, I know. No, you ever wrote a paper? Write a paragraph. You write a paragraph, then you try to proof it. You're skipping the words because you know what you just said, you know, and you're overlooking grammatical errors, sometimes misspelled words because you knew I just typed it and I know I got it right.
And you ask a friend.
And look, what you got?
Oh, you missed all these words.
Right. And that's just a program. And sometimes in programming you got to put it aside. But I'm not saying don't work on it for hours at times, because sometimes you get rolling and you're working. But at times, you know, you have that block. Put it aside. Put it aside. Watch a TV show or go do something else, and then come back to it and like, why did I do that? Why is this here? What is it? And you start catching a lot of little things because now you're looking at it fresh, you know. And they just have it. Yes, ma'am.
Yeah, my English teacher tells us to read aloud what you write.
That's true too, yeah. Read aloud. You know, I remember when I was in school, when I was back in the day, I've been out 30-some years. But the teachers would tell us, read silently, you read faster, which may be true, but you're not pronouncing it and you're not saying, you know what I'm saying?
Right.
You know, because when you pronounce it, you're gonna stop and make sure you pronounce it right and go back over whatever. But just looking at it, you're like, oh, and you kind of sometimes missing the gist of what's going on.
So if you're working like 50 hours coding, wouldn't you get burned out?
Yeah, and I say you would. I wouldn't try to work that long, but I would tell you this. If you, well, a coder, just put it like this. A coder never, I would say, sleeps. And when I say sleep, I mean they always thinking. And what I mean by that, you might be sitting at the dinner table eating. You're like, oh man, and you go there. You might be walking. You know, it's like, oh, that if statement. I need to just that. You know, it's like it's something that's in you. It's like you know you got that problem you're working on, and you know you going about your day. But it's when that thing hits you, it's like, oh, I gotta get down. I gotta sit down and do whatever. You know, that's a programmer's life. You know, because what? It's almost like a songwriter. If you don't write it down, then that little tool might not ever come back to you, and it might take a lot more to kind of get it back. So you stop, man. You okay? Oh wow, I got that one out the way, and you're moving on and doing whatever. And people look at us sometimes, look at you crazy sometimes. And students, I'm gonna tell you another thing. A lot of times when you code, say you write your programs, like the little programs I give you, and say you're struggling, man. The first one I bombed on, I didn't turn in. And you working on the program, whatever, and all of a sudden somebody hear you, I got it, whatever. And like, what's wrong with him? But you're so happy that you got that program right. You just jubilant. You're just saying, hey man, I got it, and that's just the way it works. Yeah.
Yeah, that's actually a perfect example because I was doing the one that we were doing in class just now, and I kept getting error after error.
Right.
It's like, what am I getting wrong? It was the
Oh,
parentheses.
Oh yeah, on main, yeah, right. Every parenthesis matters. Every punctuation matters. You understand? All that stuff matters. Pay attention to details. It matters.
So where do you and do you not put semicolons?
Well, I would give you this advice. All right. If you look at this program here, all right, these are what header files that we load. Libraries. You don't put them on these, okay? You never put them on those. This is a statement that loads the standard library, okay? So that's done. But now look at this. Main, int main. Int main is a header, a function header. You never put a semicolon on a function header. Now, the main function begins here and ends where? Here. You don't put semicolons on that body for that function. Any function. Well, right, because we have classes and structures. You have to use semicolons, but that's something different. That's another class. Look here. You got an if statement, right? You don't put a semicolon here. If I put a semicolon here, I'm cutting off the if statement, saying I'm finished with it.
Right.
So I don't care whether sex is male, female, whatever. It's going to just continue on with the statement by statement like, oh, I don't need to worry about that if because I read the if statement. It says semicolon. I'm done with it. And now I'm going to continue with executing my code in my program. So you don't put a semicolon here. But look here. Now the body, this is the body of the if. But then what? Every statement, C out, C in, whatever. If I had a assignment statement, semicolon. You understand? I would have semicolons.
So don't put it on the function stuff or the comparison.
Right, on the if, right, correct. Because normally your main has a body. Your if has a body. Your whiles have a body. Now there's a while called the do while, which does have a semicolon at the end, but we'll talk about that too. You understand? So it's a lot of little rules you gotta remember and understand, because that's C++. Yeah.
How many functions did you have in one program?
This is the thing that I see. And if you look back in the day, most things was designed with limitations in that fashion. But like, you have to have so many of this, you have to have so many of that, otherwise, then it ought to bomb out. nowadays, being that we have so much RAM, and this is my opinion, it's based on the amount of RAM you have. As long as you have enough RAM to run it, it's okay. You got me? As many functions as you can, as you're gonna call it, go out, whatever. As long as you have enough RAM to load it and run it. So it's no limit in a sense. Because if you look at, and this is just an application, Excel. Excel at one time had a limit as to the number of lines you could have in the program. Right now it's like it's unlimited to like the amount of memory you have. You got what I'm saying? So stuff like that. They don't limit most of the stuff anymore. The limit is the amount of RAM that you have on your system. All right. Now, any other questions? But everybody kind of understanding whatever and got those little tidbits of what not to do, whatever. Because I'm telling you, that'll help you over a weekend, man. You looking at stuff, or you might email me, Mr. Sylvester, I got this error, look at this code. Some people do that. Sometimes I'll look at it and I'll make a comment to the area where you might have an error. I won't tell you what the error is, but I'll say, check out statement whatever, or look at this variable or whatever, and then you could check it out. All right. Now here we talk about data conflicts, but in C++, you really don't have data conflict because a character data can be converted into a decimal, right? Like remember that letter A can be converted to 65, right? But you really want to kind of stay with at this point while you're starting the program, numbers with numbers, right? So here, if you see here, you got char code, int age, float amount. Amount equal age, that would be valid. You're taking an amount that's a what? A floating point, right? Right, class? Amount is a floating point, and I'm storing it in the age, which is what data type? A whole number. So what you think would happen if I have 300.85 in amount and I store it into age? What's going to be stored? Well, no, scratch that. I'm going backward. If I have age equal 55 and I store age into amount, what's going to be stored into amount? 55.0, right? So if I take, if amount is equal to 300.85 and I store 300 amount in the age, what's going to be stored in the age?
It'll be the whole number.
300. It'll throw away the decimal place because amount can only hold a whole number. All right? Now, look at the other side. Code age is equal to code. If age is 65 and code is a char, what is going to store in the code? It's going to store that 8. But I'm saying you don't want to deal with that now. We just trying to deal with our logic and get everything going. But you want to stay away from character to numeric. All right? Code is equal to amount. You want to kind of stay away from that. All right? Code is equal to age. You want to kind of stay away from that at this point. All right? Okay? All right. So, is that time? Hello?
Yep.
It's almost that time.
No, it is that time. It's 6:45.
Yeah. All right, so let's see what I have here. But be looking for those assignments. Look here, class. These are the operators in C++. Addition, subtraction, multiplication is always the asterisk symbol. Dealing with computer science, if you're in Excel, the asterisk symbol. In a compiler, the asterisk symbol. Division, all right? Now, there's something called a modulus. It's the percent sign, all right? What the modulus does, it returns the remainder, okay? Miss Jane, if I said x is equal to 7 modulus 6, what's x is equal to? Do your long division and tell me what the remainder is.
Sylvester.
Yes, sir.
Actually, here.
We don't put these, we only put these twice, right? We don't put any of these twice, right?
No, we ain't dealing with that yet, with the double equals yet. Yeah, not yet, don't, that's with the if step.
Okay, just making sure. And mod's like
Mod, okay, 7 modulus 6, gonna give you a answer of 1.
Okay.
6 going to 7, how many times? 1 time with a remainder of 1. So 17 modulus 15 is
Two.
2. 15 going in the 17 1 time with a remainder of 2. 10 modulus 3, 1. 3 going to 10 what? 3 times. All right, 9 from 10 leave 1. Everybody understand that? That's how the modulus work. All right, and then you have that little caret for the exponent. All right, and it works in certain compilers. All right.
Thank you.
All right, so we'll pick up here on next class period, and then pretty soon we will be having us a test. Right? Hello, class. Yeah. All right, but we'll go over this here.
So,
Yes,
so
sir.
I did explain this, I have to clear it.
Mm-hmm.
And then, so I could do if that equals M, equal this, and then another one with most of this, but change it to if it's a female.
Yeah, and you can do that. Yeah, you can do if step. See, you that if statement you can put it anywhere, however, whatever.
And it'll run that
Right.
if that variable is.
Now, there's another thing with the if statement. Now, there's the